Alright, this is the last question, question 10. Knock the microphone over there. Question 10 from May 2015, paper 2, time zone 1. Let's have a crack, 16 marks, we'll see how we go. So we've got a function f defined between 0 and 10. The following diagram shows the graph of the derivative f dash. The graph of f dash passes through 2, -2 and 5, 1 and has intercepts at 0, 4 and 6, just making it clear what we can already see from the diagram. The graph of f has a local maximum when x equals p. State the value of p and justify your answer. So how am I going to go about this? Well, if I'm working on part A, for a maximum to occur, f dash of x has to go from a positive through 0 and then to a negative. It's going to have to move through that range there, isn't it? Now you can do f dash x. You could be really great and have f dash of k, f dash of k minus delta x, f dash of k plus delta x. Same thing. You've got to show you understand how a maximum occurs, going from a positive gradient, a 0 gradient, to a negative gradient. At what point do we go from a positive 0 to a negative gradient? Right there, isn't it? Positive, here it's above the line. 0 at 6, negative after 6. So therefore, max is at x equals 6. And we need to say the value of p. Therefore, p equals 6. And we've got our first 3 marks. Write down f dash of 2. This is nice. Write down. They're easy questions, aren't they? Write down. They really just want us to... They've given us the information somewhere on the page. They just want you to show that you know what it is. So, there's a graph of f dash of 2. So I go ahead and I find 2. When x is 2, f dash of 2 is negative 2. That's easy enough. F dash of 2 is negative 2. Nice giveaway marks there. We're happy with those. We'll give some more information first. Let's scroll down and have a read. The graph of f... Note there. Let g of x equal the log of f of x. And f of 2 equals 3. So they're giving us a bit of information there. Find g dash of 2. G dash of x. Well, let's see what I've got. G of x is the log of another function of x. What is it when I have two things happening to the one x? Two functions of x. We're doing derivatives. Got it? Chain rule. Two things happening to the one x. So therefore, I am going to let g of u equal the natural log of u, where u equals f of x. That seems fair enough. G dash of x is going to be g dash u multiplied by u dash x. If you want to write it the other way, dg du by du dx. What's the derivative of g of u? The derivative of log u is 1 over u. And I'm multiplying that by the derivative of u. Well, if that's f of x, I'm going to have f dash of x. Now remember, u is the same as f of x. So what I really have here is g dash of x equals f dash of x over f of x. Well, that's great, Chewy. You've gone ahead and done that, but how does that help me find the values here? What do I want? G dash of 2. Well, G dash of 2 is going to equal f dash of 2 divided by f of 2. Now we're somewhere, aren't we? We've figured out f dash of 2 and we've been given f of 2. So G dash of 2 f dash of 2, we wrote down the other bit was 2, and this is divided by, oh sorry, negative 2, Put it down too long. Negative 2 over 3. If I can see, yep, there was f dash of 2 was negative 2. F of 2 they gave us was 3, so g dash of 2 is negative 3. Finally, the last bit. Oh no, not the last bit, because we can see there it continues on the next page. But we'll keep going anyway. Give myself a bit more room. Verify that ln3 plus the integral from 2 to a of g dash x dx equals g of a, where 0 is less than or equal to a less than or equal to 10. Alright, let's go ahead and verify this. There's my cursor. I'll try and write it over here. So D, what am I verifying? Natural log of 3 plus the integral from 2 to a of g dash of x dx equals g of a for any value of a between 0 and 10. Well, let's just work on this left-hand side and see what I get. It sounds to me like we're going to have a bit of ln3 cancelling out. I'm just going to be left with g of a. We'll see how that goes. My left-hand side is going to equal the natural log of 3 plus, here I'm doing the integral from 2 to a of g dash of x, so the integral of g dash is obviously just going to be g of x. And first I'm going to sub in a, then I'm going to sub in 2. So this is the natural log of 3 plus g of a. We don't have a value for that. And then I subtract g of 2. Now, have we got an expression for g of 2? We do g of x equals the natural log of f of x. Okay. Just let me pause for a second. I'm being summoned. Alright, the Inquisition is over and the maths continues. So log of 3 plus g of a minus g of 2. So now what we've got to figure out is what g of 2 was. Whereas, oh, my pen's up a little bit high. So this is natural log of 3 plus g of a. Now you could just cheat. You know it's going to be minus the log of 3, which is g of a as required. Give it a tick. Alright, equals right hand side of something. But how did I get that log of 3 for g of 2? Remember, g of 2 is ln of f of x, so it's the log of f of x. Now really, although we've just put that in there, we should say that's the natural log. I wish this cursor was just a little bit larger. Natural log of f of 2, which we can then write in the next line as the log of 3, because we've got f of 2 given to us. So there we go, equals ln3 plus g of a minus ln3, I was leaving off that other bracket there, which is g of a, which equals our right hand side, and we are done. Alright, one part to go. This question continues on the following page. So we go over to the following page. Now, I'm going to take that little bit with me. You'll see I've already put it there, that d value, because why do I need that? The following diagram shows the graph of g dash, the derivative of g. Great. The shaded region enclosed by the curve, the x-axis and the line y equals 2 is a. That has a value of 66 units, so that's negative 0.66 would be the integral. B has an area of 0.21, so the integral there would be 0.21. Find g of 5. Now, there are a few ways you can do it, but I'm going to use this right here. They told us a formula for g of a. Remember, with these questions, they tend to follow on from each other. So, let's use that information, see how we go. So here I've got g of 5 is going to be equal to the natural log of 3 plus the integral from 2 to 5 of g dash of x dx. Now, conveniently, they've given us this diagram here, which goes from, I might actually write it in here, 2 to 5. So this is the log of 3 plus the value of this integral is just the sum of those two numbers, negative 0.66 plus 0.21. We can see that. That would be the value of that integral. So g of 5, we're still working with here, is going to equal the natural log of 3 minus 0.45. And what looks like a difficult question is actually quite easy. Now that's an exact answer, so I don't need to write anything else. If you wanted to, you could of course use your calculator just to confirm it, but why would you? I'm not sure. We'll go ahead and do it anyway. So here you can see negative 0.45 plus the log of 3, 0.648612. So that's approximately equal to 0.649. But as I said, if you can get an exact answer like I have there, I would stop there. But it's perfectly alright, and if you feel more comfortable using your calculator to do that, that is fine as well. Alright, that paper is done. We will see you when I next make videos for paper 2 time zone 2. Hopefully that's enough to keep you going for a while though. Cheers guys.